In section 3.1, our learning objectives are to identify and plot points on a coordinate plane. And our key vocabulary for this section will be quadrants, the coordinate plane, and an ordered pair. So as we start thinking about this, this item, which is a flat grid with a horizontal axis, the x-axis, and a vertical axis, the y-axis, is called the coordinate plane. So you've probably seen this before and you've probably been graphing. And each location on this coordinate plane takes the form of an ordered pair. Okay, and an ordered pair basically tells you how far from the origin is this point horizontally and vertically. Okay, so positive horizontal change is to the right, negative horizontal change is to the left, positive vertical change is above, and negative vertical change is below. And the quadrants run counterclockwise. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And you can see in quadrant 1, x's and y's are both positive. In quadrant 2, x is negative, but y is positive. In quadrant 3, x and y are both negative. And in quadrant 4, x is positive, but y is negative. Now, if we wanted to go ahead and identify all these different points, we're again really counting horizontal change, which is x, and vertical change, which is y, from the origin. So if we look at point A, it's 1, 2, 3 to the right, that's positive 3, and down 2, that's negative 2. If we do B, it's 0 change horizontally, and it's down 1, which is negative 1. If we look at C, it's 1, 2, 3, 4 to the right, and up 1, 2, 3, 4. So that's also positive. If we look at point D, it's 1, 2, 3, 4 to the left, that's negative 4 horizontal change, and 1, 2, 3 positive 3 vertical change. Okay, I'm not going to finish doing the rest of the points, I think you get the idea. The important point is that each point is identified by an ordered pair that measures the horizontal change and the vertical change from the origin, which is 0, 0. So if we want to plot some points in a coordinate plane, let's plot point W. It has a change of 3 horizontally, 1, 2, 3, and down 2.5, 1, 2.5, and that's point W. Point R is 1, 2, 3 to the left and 0 up and down. That's plotting point R. Now, if I want to graph a function, in this case, they're giving me a specific domain, and we're going to work on expanding on this as we continue through the chapter. So what they're telling me is I'm going to use all these different inputs. The domain is the collection of all the input values, which are the values of the independent variable, which is going to be denoted by x. So I'm going to take negative 6, negative 4, negative 2, 0, and 2. And for me to find the matching y for an input of negative 6, I take negative 6 and I plug it into this equation. So y is equal to 1/2 times negative 6 plus 1. Well, 1/2 times negative 6 is negative 3 plus 1 is negative 2. So 1, 2, 3, 4, 5, 6, negative 2. When I plug negative 4 in, it's 1/2 times negative 4 plus 1. 1/2 times negative 4 is negative 2, plus 1 is negative 1. So 1, 2, 3, 4, negative 1. When we plug in negative 2, 1/2 times negative 2 is negative 1, plus 1 is 0. So that would be here. When we plug in 0, 1/2 times 0 is 0, plus 1 is 1. And that's right here. And when I plug in 2, 1/2 times 2 is 1, plus 1 is 2. And there we go. So this then becomes a line segment for this specific domain using this equation. Okay, let's take a look at another example. If we wanted to graph a function that's represented by a table, the table shows the change in value of stock over 5 days. So we're going to use 1, 2, 3, 4, 5. So that we're going to make the x-axis is the independent variable, which is days, and the vertical axis is going to be dollars. Okay, but you're looking at this, these are all in tenths. So I'm going to have this be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 1. Right? And then this is 0.1, 0.2, 0.3. So at 1, we're at negative 0.3. That's 1, 2, 3 down. At 2, we're at positive 0.1. At 3, we're at positive 1.5. At 4, we're at 1, 2, 3.5. And at 5, we're at 1.1, which is about there. So this is what we would call a scatter plot, where I've taken actual data and I've just plotted it onto the graph so that we can start to look at what does this situation that we're modeling look like. Okay, so we've graphed from a table, we've graphed with the supplied domain, we've graphed with supplied ordered pairs, we've gone ahead and identified the ordered pairs for individual points, and we've talked about all the different quadrants.